Okay, I think we're all set. Yes, so good morning, everyone. My name's Aliyan from Natural Resources Canada, and thank you for joining us today. Today, we're going to be talking about something that matters, how we respond to emergencies when lives and infrastructures are at risk. So today, I'll be talking about, as Scott mentioned, the discrete global grid system pilot project that we have ongoing, utilizing artificial intelligence, mainly for emergency management. So this collaboration is led by OGC and co-sponsored by Natural Resources Canada with international partners under the OGC umbrella. So this is about building a foundation for interoperability for standards that are being integrated to work in real-world crisis. And by the end of the session, I hope to share why DGS plus AI is a possible game changer for emergency management, and also the progress we've made and where you as colleagues can also help us with the future use. So here's a look at what we'll be going over today. First, we will discuss the problem and context and why this matters. Then we'll take a look at who's involved and how we're approaching this pilot. We'll also look at what is being tested, some of the early results, and the architecture that ties it all together. Finally, we will talk about deliverables, next steps, and also the benefits this pilot unlocks. So this will be a journey going from fragmented data into a common operating picture powered by standards. So as the title hinted, our focus is on emergency management as the problem. Today we face almost a paradox. We have more data than ever, yet it's still harder to use it when it really matters. So disasters are increasing in frequency and cost, but the issue is that data live in silos and with different formats, scales, and different sources as well. So when the time is critical, this fragmentation of data slows down our responses, and this makes our challenge very clear, that we need real-time integration, interoperability, and a common operating picture that emergency managers can trust. So that's where this standard and this DGGS pilot comes into play. A little bit more about the problem. So every disaster tells us the same story, that data exists, but it doesn't know how to talk to each other. And we have formats clashing, scales differing, and sources being scattered. And like I mentioned, this results in delays in decision-making when speed is needed the most to save resources and help people. So this is all due to data fragmentation. Sometimes the existing data does not even get used, and decisions are made without utilizing all the data. So this is why we need a system that unifies geospatial information, making it accurate, scalable, and interoperable as well. So that way, emergency managers can act fast and confidently in making these decisions. So OGC was selected to lead this effort due to its ability to bring technology, resources, and people together in a timely fashion. So why are we going with a discrete global grid system, you may ask? Well, as we know, traditional GIS was built for paper maps, which is a flat view of around Earth. So that's all, as we all know, that introduces distortion and complexity. So DGGS, on the other hand, flips the paradigm. It's digital first, representing the Earth as a spheroid divided into uniform cells. So it's much like a spreadsheet of the Earth, you can see, and you can see an image of how it looks on the right there. So this means that we have consistent resolution, accurate analysis, and a system that inherently is designed for integration across data sets across the globe. So it's not really a new format. It's a foundation for global interoperability, and it's going to work perfect with AI-driven workflows, allowing us to easily work with AI as well. So just to recap, the challenges we discussed was emergency managers facing fragmented data and dealing with different formats. DGGS and AI is proposed to address this issue by converging the technology. DGGS provides spatial backbone per se, and the AI adds the intelligence element to it as well. So the pilot in action for the DGGS pilot, we proposed a Manitoba flood scenario from in Canada, which is a place known and prone to floods. And we also worked with the Emergency Management Manitoba to build requirements for this pilot, including integrated radar satellite imagery called RadarSat for Canada. And we also use our country's census data and also Canadian climate forecasts. So this is something traditional GIS couldn't necessarily easily do at the grid level in an easy and intuitive way. So the aim for our result was improving the capability to answer questions quickly, such as the identification of at-risk populations or targeted evaluation alerts. So our vision for the DGGS and AI is to be as a foundation for geospatial decision-making across different sectors. So now that you're a bit more familiar with how the work with DGGS works, I want to go over some of the people that are bringing this all together. Just a little bit more context about NRCan. So Natural Resources Canada is a strategic member of the OGC. That means NRCan helps set priorities, influence technology, and advance initiative aligned with Canadian goals. So through OGC, we have access to cutting-edge technologies and a global network of experts. And by shaping international standards, we ensure that DGGS AI pilot reflects Canadian values of interoperability, sustainability, and inclusivity. So this aligns with our interest in influencing how standards are built to help those that live in Canada and beyond as well. So this pilot is internationally co-sponsored and is being led by the OGC, and NRCan is working with the European Space Agency, the United States Geological Survey, and France's National Space Agency, CNES. Each partner is bringing in expertise in Earth observation and geospatial science. And Natural Resources Canada was a key driver in developing the requirements for the pilot with OGC. But the increased and global collaboration allows this pilot to reach and have more credibility. So together we're building a global interoperable solution, which is both technically robust and policy aligned across borders. And at the bottom, you can see the participants that are involved in this pilot, which is being led by OGC, as I mentioned. So let's get a bit more into the details on what exactly is being tested in the pilot. First, I'll start off with DGGS. As you can see on the right-hand side, there are many different types of DGGS. We can have rectangular, triangular, hexagonal, and they all have their own strengths. But the issue is they don't naturally talk to each other, nor are they standard, which causes a problem. So the OGC, as Scott just mentioned, has published the DGGS API core standard to solve this issue, but we need a way to test it in real-world conditions. So that's why we're integrating different data sets, such as Earth observation, climate, and statistical data to see if the API can support real emergency tasks. So the big question is at the bottom, as you can see, is can AI help make DGGS even smarter? So we're using AI to enhance disaster response by integrating different data sources and improving predictions and generating insights. So this pilot is designed to find out if that's possible. So a little bit more about the information about the scenario that we have for the Manitoba flood that this pilot is testing. So like I mentioned, emergency managers need a single unified view, a common operating picture to understand what is happening to support disaster decision making. We're testing whether the DGGS can deliver that in a Manitoba flood scenario, and if it can support integration analysis and visualization for immediate response, and also long-term planning under a changing climate. So we're testing with different forecasts and possible flood volumes, and also for triggering evacuation alerts and we're integrating all these diverse indicators in this pilot. So the AI is basically bringing it all together, standardizing automated analysis and chatbot interfaces to make geospatial tools a little bit more accessible. So just going back to emergency management. So this isn't just about mapping, it's more about the context and data because decisions depend on understanding who is at risk and finding out what infrastructure is vulnerable and how conditions are changing. So we're hoping, and DGGS is allowing us to do that by being a spatial backbone to unify all these diverse data sets and help us make calculations or queries with the cells of DGGS. So let's look at some of the early results that we've gotten from the pilot and also the architecture of the pilot. So a few of the accomplishments so far. The pilot started in the summer, and here's what we've achieved so far. Every participant of the pilot has stood up their own OGC DGGS API implementation, and they've published data in DGGS, including vector, raster, and time series, including data cubes as well. So they built clients and used AI for natural language queries to work with the data there. They have also updated and shared libraries like the discrete global grid abstraction library, which is a shared software toolkit to make different DGGS systems work together. And we hope to finish this pilot by February 2026. So as you can see, the timeline is very short, and we've had some good results during that time. So let's look at a few more results. So this is where things get interesting. So in this example, you can see one of the clients provided by Terraframe, which is a US company that poses AI-based chatbot questions to the DGGS, as you can see on the left, and provides related answers in real time about showing flood-related data for a city in Manitoba where a hypothetical flooding scenario is being tested. So they tested the AI client by asking questions like where are high-risk flood zones in Manitoba. The system queries the DGGS grid, integrates the climate and imagery layers, and returns actionable insights straight to the user. So the cool part of all of this is that no GIS expertise is required, and it's just a question in plain language that is being asked with AI. So here's another example from the pilot. It's utilizing a spatial knowledge graph query. So instead of raw data, we're asking for relationships now. How flood risk connects with population density, infrastructure, and climate trends. The AI-DGGS client translates the natural language question into structured queries, then maps the results into a knowledge graph, as you can see there. So this is quite cool to see how standards can meet semantics, turning geospatial data into actionable intelligence. So here's another example from the pilot delivered by Hartis from Greece, which shows some of the geospatial AI interaction as well. In this example, you can see we asked where are high-risk flood zones in Manitoba, and the system parses the question and queries the DGGS grid with the integrated climate data and or imagery data, and returns a clear answer. So same thing as before, no specialized GIS training required. It's just a question in everyday language that's being posed, and it's returning results quickly. So this is what we're testing and demonstrating, that the interoperability of what AI can be made possible through natural language interaction. Getting a little bit more technical, here's the architecture that the pilot is building. So we're testing multiple DGGS grids connected through OGC API endpoints serving climate, weather, and emergency data. On top of that, the analysis and visualizations of clients and AI tools that make it intuitive as well. So it's not a closed system, it's open, standard-based, and designed to scale across agencies and borders. So it's a digital ecosystem for geospatial decision-making, which can be used for many geospatial analytics, not just for emergencies like we have in this scenario. So a little bit more technical, this is the DGGS client-server peering diagram. This diagram shows how multiple DGGS servers provided by participants and AI-enabled clients connect through using the OGC API standard. It displays how they're all interrelated. So this is the conceptualization of real interoperability that we're aiming for to share and exchange geospatial information. So this is the technical backbone of the pilot, open standards enabling real-time integration across diverse systems. So let's now look at a few of the deliverables and next steps for the pilot. Here's what the pilot is planning on delivering or has already been delivered. First, we had stakeholder workshops to ground this work in real-world needs. So this included emergency management professionals engaging with the OGC participants, companies and organizations. Secondly, we had at least 2 interactive DGGS prototypes showcasing disaster, statistical, and environmental and AI capabilities. Thirdly, we had interoperability demonstration to test the standard under real-world conditions with the hypothetical scenario. Finally, a comprehensive report is also a deliverable for and online demos to share the results and also the lessons learned. So this is demonstrating moving from a concept to a reality. So another requirement that we have is to maintain the system for at least 1 year after delivery and completion, which is in February 2026. So here's a look at some of the expected benefits and impacts that this pilot can have. Firstly, we can have better testing of tools and decision-making for emergency response, having faster and clearer insights when time matters the most. Secondly, we have a standardized approach of managing climate and disaster data, integrated and visualized through a common operating picture. Thirdly, we are using enhancing AI applications for government, industry, and research, and we're simplifying how AI is being utilized across for geospatial problems. And finally, a demonstration of DGGIS capabilities to inform future operational use in Canada and beyond as well. So to conclude to today, I guess, DGGS has, what we found, has strong potential for disaster response, but it needs real-world applications. So this pilot allows us to move from research to semi-practical deployment, and the success depends on interoperability and adoption. And that's where standards are most important. So AI needs spatial context, and DGGS is delivering that. And in this pilot, we had AI clients are being tested with open APIs, built workflows, linking tools and data sources. And the aim is to demonstrate that this convergence can work. So with that, I would like to thank you for the opportunity for sharing this pilot and its progress with the ISO community. We believe it's critical in making standards global and building a better future that utilizes geospatial data for answering these pressing questions to help people and save resources. So the aim of this pilot is to help people and develop the technology that enables better emergency response and knowledge. So thank you once again for your time. And this work, I would like to emphasize that this work is only possible through collaboration across agencies, across borders, and across standard bodies like ISO and OGC. And with that being said, we would like to also invite your feedback, your question, and your ideas. So feel free to email us to myself or my colleague Graham Wilkes or Ryan Ahola for future details on the pilot and NRCan's involvement in the work. Thank you.
Thanks, Aliyan. This was great. We ended on the ultimate demonstration of practicality, starting with your early slide where you noted that we have to have a digital-first mindset. So for those building these systems and working with the data, having that digital-first mindset lets us integrate the data far more easily to get our at least foundation built. But also from the practical standpoint of the stakeholders, if I live in a house in Winnipeg and I want to know, am I going to be underwater after this next storm? I want to ask that question in simple, plain English and get an answer that's grounded on real technical information. And so this is a really good demonstration. So all of you in the room and online who've wondered about what all can we do with these cool DGGS things that look really good on the screen with that mesh, there's actual real practicality behind all this. And I think this pilot's really been a great example. So thanks for that, Aliyan.
Thank you, Scott.
Do we have any questions online or in the room? Well, people wait. Aliyan, you mentioned towards the end that the intent is to leave a operational system up for a year for people to use. Do you expect that system to be available to other experts in other parts of the world who may want to just experiment and understand how all this fits together?
Yeah, so I think, Scott, like I mentioned, we'll be having and releasing, or we'll be having a final report that has the online demos. So people should be able to access that and look at all of that as well. And we'll also have this operational for one year after the deadline of February 2026. So we do have one other question in the room, Nicholas.
Hi, Aliyan. Look, those natural language interpretation bits are amazing. I mean, this is really a next level demonstration. Really impressed also, and I'd like to talk to you more about the use of the knowledge graphs to provide that extended context. But my question is actually about the use of the DGGS. It seems like you've got several really impressive bits of this demonstration, but what is the DGGS demonstration bit that is separate from using just say a regular grid? So if you're taking all the data sets that were in here and associated them with a regular grid, are you using DGGS scale changes or something like that that goes to the value add of the DGGS as separate from query interpretation, knowledge graph context, and so on?
Yeah, so we're testing the DGGS API, OGC API in particular. So I'll just go back to the slide. I think that is a question. Yes, so we're utilizing the OGC API for DGGS API to answer a lot of these questions and connecting it. So this allows us to, like I mentioned in my presentation earlier, we have a lot of different DGGS, but they don't have a way to talk to one another, and it can be difficult to do that. So that's why we're using the OGC API. So even when we have different types of DGGS, we are still able to talk with one another and have a connection. So this is a more standardized way to solve that. And yes.
Do you actually, the providers of the APIs, they're using completely different DGGSs under the hood?
I'll have to verify that for you and give you the exact details on what they're using. Because there's different testing being done. Maybe Scott, I don't know if you can provide some of the details on what's being done, but just to summarize, I think the standard is allowing us to do that, Nick, yeah. And we are able to.
Because our small tests, I mean, we can easily use APIs on top of a single DGGS, everyone, but what we've never been able to do, and this is what I'm really interested in, is whether you've got, triangular and hexagonal and other DGGSs, and yet the API still allows you to use them all as if you don't care what DGGS is in use. That's the thing that we haven't been able to do.
Yeah. No, I think I can show you the details on the exact details on the pilot that we're testing.
Yeah, Nick, and certainly the intent with the OGC API DGGS is to support any type of DGGS and allow interoperability amongst them. But some of that gets obviously quite advanced if you start trying to map between different cell dimension sizes and types, and how your information might be collected, collated, or aggregated. So that's almost an implementation detail. But in theory, right, an API should let you at least hit all these independently and fuse some degree of information amongst them all.
Okay, any other comments or questions? If not, you can definitely reach out to us via email if you do have any other comments or questions later on as well. So thank you once again.
Well, thank you everyone in attendance online and in the room. We greatly appreciate your attention to some of the work we're doing at OGC. We love offering this session. It looks like I'm now running 10 seconds over, so we've done pretty good on time today. Do feel free to reach out if you have any questions about anything that you saw today. And if there are things you want us to brief on back to ISO TC 211, let me know. If you're following any other OGC activities and would like an update, and I'll be sure that we can get that into upcoming meeting agendas. So thanks everyone, and thanks Sandra and Mats very much for allowing me to participate today.